Okay, in this video I'm going to show a couple of more examples on the topic of counting or combinatorics. And here what I've got is a couple problems. First one is to calculate the number of 6 lists that can be made out of the elements of a 9 set. And in these lists, repeats are allowed. And so we have a set with 9 elements in it, and we want to make a list of 6 elements from that set when repeats are allowed. And when repeats are allowed, we're going to use the product rule and say that the number of 6 lists, maybe I'll write that out, 6 lists possible is equal to, well, we're going to build a 6 list in 6 steps. 3, 4, 5, 6. And at each step of the way we're going to ask how many choices do we have of filling the element in the list. And when repeats are allowed, we're going to have all 9 choices every step of the way. And we're going to have 9 raised to the 6th power. And I've already calculated that on my calculator somewhere here. And that comes out to be where is it? 9 raised to the 6th power. It is 531,441, if I'm not mistaken. In any case, this is a special case of the general formula where if we have a set A with size n and we want to make lists of length k, then we're going to have the number of k lists possible with repeats is n we're going to raise n to the kth power. Okay, and we have a special example, a special case of that above where n is 9 and k is 6. Okay, so it's n to the k is the general formula for that. Okay, so the next problem is essentially the same thing, except here repeats are not allowed. And the number of 6 lists possible with no repeats. This is called a 6-element permutation, or a 6 permutation of the 9 set. And if you use the counting principle, we'll build our 6 list in 6 steps again. But this time we have 9 choices for the first one, but only 8 for the second one because we've used one and we're not allowed to repeat it. 7, 6, 5, 4. And this is 9 factorial over 3 factorial, which is really a special case of a more general formula where it's very important. We call this Pnk, and this is n factorial over n minus k factorial. And so this can be written as 9 factorial over 9 minus 6 factorial. And the number that comes out here is a lot less than if repeats are allowed, and it's only 60,480. And so you should be happy that I don't ask you to list them all out in the problem. In any case, this is an example of the permutation formula. Okay, the Pnk formula. And so I hope those 2 examples help.